Hello and welcome to Maths with El Profe Lo. I'm going to do some elementary number theory, looking at some exam style questions and working with congruences. Okay, so this question asks us to find the perfect squares modulo 13. So in other words, find what would be the possible remainders, right? What would be the possible remainders when you group any perfect square in groups of 13. Okay, so a few things here, a few things. So our remainder, all right, so essentially we're trying to say, hey, r squared is going to be equivalent to something modulo 13, all right, where r is going to be some integer. Okay, well, a thing to note is that 13 minus r squared is equal to 13 squared minus 2 times 13r plus r squared. And so because this is multiplied by 13 and this is multiplied by 13, we can say that 13 minus r squared is congruent to r squared modulo 13. All right. What that means for us is that we will be able to shorten some of the work that we need to do. All right, so this may be best done by exhaustion. And what do we mean by exhaustion? Well, we could say, well, what if r is equal to 0? Well, if r is equal to 0, it's going to be equivalent to 0 mod 13. Okay. And if r is equal to 1, that's going to be equivalent to 1 mod 13, right? I guess I should probably write this a little bit better. I'll say, hey, we would say that r squared is going to be 0 if r squared is equal to 1, right? And this is saying, hey, I'm working with r equals 0 and I'm working with r is equal to 1, right? Well, my next perfect square would be r squared is 4, and that's equivalent to 4 mod 13, right? So I'm writing out the first few to see if I catch a pattern that might help me with this. Right? And if I look to the next one, right, we would say if r squared was equal to 9, that would be 9 mod 13. And if r squared was equal to 16, that would be 3 mod 13. And so far, we have 1, 2, 3, 4, 5 different solutions. Okay. If I look at 5 squared, right? So if r squared is 25, well, that's going to be equal to, let's see here, -1 mod 13, or excuse me, equivalent to -1 mod 13, because 25 is 1 less than 26. But of course, if I wanted to be working with non-negative values, that would be 12. Okay. Then I have, what if r squared was equal to 36? All right, and r squared being 36, well, that's 10 more than 26. So that's going to be 10 mod 13. All right. Now, this little piece up here is why we should be able to say, well, these are all of the equivalent classes. And here's why. Okay, that if I have r squared is equal to 49, right? Well, 49 is going to be what? Right? 49 is 10 more than 39. So that's 10 mod 13. And if r squared were equal to 64, right? Well, 64, if we think about what we have, if we think about what we have on multiplications by 13, we have 13 plus another 13 plus another 13 is 52. Well, 64 is 12 more than 52, and so this would be 12 mod 13, right? And if r squared were equal to 81, right? Well, let's see what happens there, right? If I add 13 again, right, that's 65. If I add 13 again, that's 78, right? And if I add 13 again, that's 91. So we could say that 81 is 10 mod 13, or excuse me, negative 10 mod 13, which would be 3 mod 13, right? And what we have then, and it may not be as easy to see this pattern, is that we're starting to repeat our remainders when grouping in 13s. And the reason for that is the following, right? Well, 13 minus 5 squared is equal to 7 squared, which is going to be congruent to 5 squared modulo 13. And that is, in fact, what we see here, right? That if we see, okay, let's see here, and actually, messed this up, 13, that would be 8, right? And that is, in fact, what we see, that if we look at what we have as a remainder with 5 and with 8, we see that that has the same remainder, and it's because of this property, right? And if I was going to look at, well, what's 13 minus 6 squared? Well, that's the same as 7 squared, which would be congruent to 6 squared modulo 13. And that's what we see here. If r was 6 and mod 13, and if r was 7 and mod 13. I'll do one more for good measure. We'll do one more for good measure. And we'll say, well, what if we had 13 minus 4 squared? Well, 13 minus 4 squared is the same as 9 squared, which would be equivalent to 4 squared modulo 13, right, based on what we've set up here. And what do we notice? That if r is equal to 9, I have a remainder of 3. And if r is equal to 4, I also have a remainder of 3. Okay? And it's a nice exercise to see, hey, what would the pattern be like for the remainders as I work through these items, okay? But this is how you can find the perfect squares modulo 13. And so my solution set, all right, so my solution set, the perfect squares modulo 13, would have a solution set of 0, 1, 4, 9, 3, 12, and 10. Right? So we have 1, 2, 3, 4, 5, 6, 7 different remainders, right? We have 7 different remainders that we could get if we took a perfect square and set it up in groups of 13. All right? It is possible to get exactly a certain number of groups with no remainders. It's possible to have 1 remainder. It's possible to have 3 remainders, but it's actually impossible to have 2 remainders. I could have 4. I could not have 5 remainders. So there is a lot more detail that you could find from this information. And that's a good way to think about other questions that could be asked on your examinations. Okay? This has been Maths with El Profe Lo. As you have questions, please reach out.